project example. In this project example, once again, we'll go over multiple facets of the previous knowledge. First facet will be random, the .random things, because for most features you're going to need some bit of randomness. But this will also go over string manipulation, .title, all those things. What example that we're going to do is rock, paper, scissors. Now, let's give that an appropriate name, so rock, paper, scissors. An appropriate name, rock, paper, scissors. Now, as I said, we're going to need to import random. So that's one of the first things. Now, we're going to have scores. So, normal score for you and CPU score. The computer. Now, let's make sure that CPU has a list to choose from. So, CPU list equals red bracket, having a list. Then, let's give it the first one, rock. Then, give it the second option, paper. Give it the third option, scissors. Now that the computer has a list that we can pick from, if we allow it to, we can get started on just the input for the player. So, chosen object will equal an input, and let's have it say A. Add A. Rock. Now backslash n for the new line. B. Paper. Once again, backslash n for the new line. C. Scissors. Now, if we just try this, you should see that these three all end up on a new line. See? Rock, paper, and scissors all on their own individual lines. Now, that's very nice. Let's make sure the chosen object is real. So always put it to $. You might think, well, how do you know if the person selects A to compare that? Do we write more statements, one for if it's A and one for if it's rock? We could do it a different way. So, if chosen object dot lower slash make mistakes. If chosen object dot lower is equal to A, then chosen object will equal rock. Very simple. Now, you can do this for them, and it makes it far simpler than having individual statements for if it's B and if it's paper, or if it's A and if it's rock. All alone. Now, there probably are other ways you could do it. In fact, I know there are, but this is the most understandable one. Because we could do if chosen object lower equals rock, or chosen object lower equals A. That would be more effective. And actually, we should do that, because it's more efficient. So let's try that actually. This is why speaking and coding can actually help you. Because you rationalize things to yourself and you realize, oh, we could do this better. So, or here, and then we can rinse and repeat this. So we're just going to copy this, back it down. We can change this to rock because it's A. Change this to scissors because it's C. Now, you can see we've got three of the statements. But there are 7 possible outcomes. If you pick rock, the computer can pick 3 things. So your outcomes are you winning, or you losing, or you drawing. And there will be always one draw, because usually it's just if you're equal. So let's do that one first. So this one's easy. Because we can just do if player choice, if chosen object is equal to CPU's choice. Now, here's where it gets complicated. If we were using the same thing from before, then we could just have it equal rock. But since we didn't, then it becomes a bit harder. So let's use the stuff from before. But it's a little bit of a failsafe. I think a bit of a failsafe. Now, the person could have it be this. First thing puts us down it. Mind. Mistakes happen, and that was a mistake. Well, let's just do this. There's no issue in mistakes. Mistakes are a common thing in coding. You're always going to have some mistakes. Never will you have your code work perfect. Unless you are one of the top, tippity-top coders in the world. It's very rare that your code will work first time. Because you can have tiny, tiny errors. Talking tiny. And if that happens, it won't work. Now, let's let CPU choose. So, CPU random dot choice. We're going to put the CPU list. Now, CPU can choose. So, let's do the if statements on how the choice can go. So, very simple. If chosen object equals CPU choice, print draw. So, if chosen object equal to, let's make that first, that's blah blah. Is equal to CPU choice. Then, if it is, then print draw. Print draw. Very good. Now, it's very easy to do this. Do 7 of these statements. Not these statements exactly, but 7 of these simple ones. So if chosen object is equal to rock and CPU choice is equal to paper, CPU wins. CPU wins. Let's make sure that score goes up. CPU score. Oh, that makes the score higher. Now you can do this. No, I can now do this again. Or if your choice equals rock, and the one equals paper, scissors, then you can print you win. Apologies about the background noise. Yeah, you could have this chosen object equals rock and the CPU equals scissors. If so, your score will go up. Now, let's just copy and paste this twice, and then edit the values. So, bang, bang. Right. So, since we've got all 6 statements, we now just need to edit them. So, if you choose paper, and the CPU chooses scissors, then they will win. And then, if you choose paper and they choose rock, and you choose rock, then yeah, if you choose paper and they choose rock, then you win. Now, let's do it with all the scissor ones. It's a very simple system. Just also repeating a lot of statements would do it. because these statements, right? 7 statements, and you've got all of what is. What you read now is just quality of life features. This is the very basics that you need. You can do this in just about 33 lines of code. No, it says 36, but that's because we've got a few empty spaces here for rebuilding. Or so it'll be 32 lines. Now, let's put this all into a loop so we can loop it over and over again. We don't need these in a loop. We want these outside of the loop, so make sure these go outside the loop. We need a loop around here. Yes. Again equals true. Let's set a gain up. Now this will loop it infinitely, which is very good, but not exactly needed. But it's good. But you could usually add a feature as opposed to exit the program. What you're going to do now. Ooh, that's quite a bit harder. Now we've got to print all the scores. So print score. That's statements. So you have a score of score. So the CPU has a score of plus third CPU score. This is the very basics, but that looping statement, like I said. So again, equals input. Do you want to go again? Y or n. Very simple. Then we do if again choice or what equals y. Then yeah, the y space on the screen. If again choice equals y, then have again equal true. Then else again equal false. What this does is if you answer yes, if you answer y, then it'll keep true, and this will make it loop again. But if you answer anything other than y, then it'll stop. So let's see if this all works. Like I said, not guaranteed to work. Let's see. Line 12. Let's see what we did here. See? Like I said, never guaranteed to work. Let's try this again. Yes, that's why you cannot string manipulate if you are assigning a string. So, .low and .upper do not work when you're doing this. Very anticlimactic, I know, but it's good to... I misspelled. Isn't it? See, like I said, never gonna work every time. So, it's good that you can see that even advanced people, even semi-advanced people, everybody will have some things not work all the time. Because if you always see perfect things going, you're gonna think you're awful and you fail. So showing things can go bad. There we go. It's working. Seems to be. We're gonna give it a test. So let's go for rock. We lost. Darn it. Let's try again. Let's go for paper. See. So something happened here. I wonder what. Let's see. This is an error. This is a clear error because we went paper But what did the computer go? Ah, see? This is another error. Sometimes errors can be not very clear, right? Most always you get the red text at the bottom, but this is clear. So we just assign something randomly. So we need a T here. Let's stop and start again. You'll always have errors. And it's good to go bug test. See? If I didn't do that there, we would have a faulty program. So let's try this again. A rock. I lost. Done. Let's try again. Try paper. I won. See? Now I fixed that error. Easily diagnosed it. Let's go again. Let's try going scissors. We drew. This is a very good example because we've got all three possible outcomes. Very lucky there. Now we know it works. Let's just try it in the program, and program stops. That's how you would do an example like that. Now, as for projects, you always have to save them. So let's save. Saved. Now that we've done that, we can exit and, well, yeah. Have a good rest of your day. I do hope you learned something. Yeah.